What we're going to take a look at today are solving compound inequalities. So just to review, today in class we talked about solving inequalities, and the inequalities you have seen so far are simple, basic one inequality symbol in the inequality. When two simple inequalities are combined into one statement using the words and or, the result is called a compound inequality. So let's just review our symbols really quickly. Less than, then we have greater than, then we have less than or equal to, and then we have greater than or equal to. All right, so let's review really quickly before we get into looking at compound inequalities. So we're going to take a look again at just what our inequality symbols mean. If we have less than or greater than, we're going to use an open circle on our number line. If we have less than or equal to or greater than or equal to. So what we're going to look at today are compound inequalities. And with a compound inequality, we could have something like this, where x is greater than 2 and x is less than 6. And we can combine that into the statement here, where we have 2 is less than x and x is less than 2. The only thing that's a little bit tricky there is where we have the 2 and the x. In this case, we have x is greater than 2, and here we have 2 is less than x. They mean the same thing, just where the x and the 2 are in relationship to that inequality sign. To graph that, we have an open circle at 2 because 2 is not included. We have an open circle at 6 because 6 is not included. And then the solution set would be all of the numbers in between 2 and 6, but not including 2 or 6. Then we have x is greater than or equal to 2 and x is less than or equal to 6. Again, we can combine it into 2 is less than or equal to x and x is less than or equal to 6. The only difference this time is that those circles are filled in because we have the equal to symbol underneath our less than signs. With or, this time we have x is less than 2 or x is greater than 6. So this time we're looking at all the numbers that are less than 2 and all the numbers that are greater than 6. And again, with this one, the 2 and the 6 do not have the equal sign underneath them with the inequality sign, so those two circles are going to be open. And then with the last one, the only difference here is that we have less than or equal to and greater than or equal to, so our circles are filled in. All right, so let's actually go ahead and see if we can solve one. We have 4 is less than or equal to x plus 2, which is less than 8. So the goal here is to figure out what x is equal to. So what we can do is make two separate equations. So we can take the first inequality sign and separate what's on both sides of that. So we have 4 is less than or equal to x plus 2. On the other side, we can take what's in the middle surrounding the other second less than sign and break that into a separate inequality. So we have 4 is less than x plus 2, and then we have x plus 2 is less than 8. And now what we can do is we can go ahead and solve. So we can undo any addition or subtraction, which basically is going to help us solve the equations in this step. So we can go ahead and subtract 2 from both sides on our first inequality. When we do that, the 2's cancel out, and we are left with 2 is less than x. For the other inequality, we can go ahead and subtract 2 from both sides as well. Again, the 2's cancel out, and we are left with x is less than 6. So now, our solution is all real numbers greater than or equal to 2 and all real numbers that are less than 6. So we can write that as 2 is less than or equal to x and x is less than 6. And then the last thing that you want to do is graph that. So we have all the x values that are greater than or equal to 2. And we have all the x values that are less than 6. And basically with an and statement, what we're looking for is what those two things have in common. And so what those two graphs have in common are only the numbers between 2 and 6. Let's look at one more. This time we have negative 5 is less than or equal to 2x plus 3, which is less than 9. So again, the first thing that we want to do is break it up into two separate inequalities. And then we're going to undo any addition or subtraction, undo any division and multiplication, and solve for x in both of those inequalities. So for the first one, we're going to go ahead and subtract 3 from both sides. That leaves us with negative 8 is less than 2x. Then we can go ahead and divide both sides by 2. On the other inequality, again, we can go ahead and subtract 3 from both sides. When we do that, we end up getting 2x is less than 6. And again, we end up with an inequality at this point, which is negative 4 is less than or equal to x, which is less than 3. So we have negative 4 is less than or equal to x, and we also have x is less than 3. So our solution is all real numbers greater than or equal to negative 4 and all real numbers that are less than 3. Now we have to graph it. So we're going to take our first inequality, which is where we have x's that are greater than or equal to negative 4. And our second inequality is x's that are less than 3. And again, we're looking for the stuff that we have in both of those inequalities or where they overlap on the graph. And so they overlap in between negative 4 and positive 3. So you don't necessarily have to separate them all the time. You can kind of treat it as one great big long string of inequalities. In this case, if you don't separate it, and again, you can still separate it. This is just an alternate method. If this makes sense to you, it might help you save some time. But I basically need to get that x alone in the middle. So I'm going to go ahead and add 1 to every single part of the inequality. So I'm going to add it to the left, I'm going to add it to the middle, and I'm going to add it to the right. When I do that, I'm left with 9 is less than 3x, and 3x is less than or equal to 12. I still have to get the 3 away from the x, so I'm going to go through and divide each part of the inequality by 3. And so I end up with 3 is less than x, and x is less than or equal to 4. So again, I end up with 3 is less than x, and x is less than or equal to 4. So to graph it, we're going to graph 3 is less than x, which basically means all the x's that are greater than 3. We're going to graph x is less than or equal to 4, which are all the x values that are less than or equal to 4. And then graph the intersection by finding where the two graphs overlap. And they overlap from 3 to 4. All right, so this time let's take a look at an OR statement. With an OR statement, basically the same thing. You already have two equations. And so what we have to do then is just go ahead and undo addition or subtraction and solve the inequality. So with this one, we're going to go ahead and add 4 to both sides. And we end up getting that a is greater than 5. On the other side, we're going to add 4 to both sides. And we end up getting that a is less than 1. So we have all real numbers that are greater than 5 or all real numbers that are less than 1. Now to graph this, we have all real numbers that are greater than 5. We have all real numbers that are less than 1. And with OR, we're basically looking for everything that's in this graph. So we don't want to exclude anything. We want everything that we see. And so that would be our graph. All right, let's take a look at another one. Again, with an OR statement, you usually are already broken into two inequalities. So we can go right ahead and solve. With this one, on the left inequality, we're going to go ahead and add 2 to both sides. And we end up getting that r is less than 2. On the opposite side, we're going to add 1 to both sides. And we end up getting that r is greater than 5. So we have all real numbers greater than 5 or all real numbers less than 2. So again, to graph it, we have all real numbers greater than 5. We have all real numbers less than 2. And it's an OR statement, so we want everything that's part of that graph. And just a reminder about interval notation. If we have less than or greater than, we're going to use parentheses when we're writing our inequalities or describing our inequalities in interval notation. And if we have less than or equal to or greater than or equal to, we're going to use brackets. The difference is that this one here does not include the number that we're looking at, and the bracket does. So this one is just greater than or less than, and for the brackets we have less than or equal to, or greater than or equal to. So examples, if we have x is greater than 4, we can graph that with an open circle. And in interval notation, it's all the values that start at 4 and go all the way up to infinity. So we start at 4, go up to infinity, and again we have parentheses around there because we're not actually equal to any values there. If we have -2 is less than x and x is less than or equal to 5, we're looking at all the values between -2 and 5. And so in interval notation, we would use brackets from -2 up to +5. And if we have -2 is less than x and x is less than or equal to 5, the only difference is that we do not have an equal sign underneath the first inequality, so we'd have a parenthesis there, but we do have an equal sign underneath the second inequality around the 5, so we would have a bracket there. With the or statements, if we had something like x is greater than or equal to 4 or x is less than 1, we'd graph it on a number line, and then again in interval notation we'd have the interval from -infinity up to 1, and then we'd go from 4 up to infinity. Always use parentheses when you're approaching infinity.